part of the course, which is conditionals, lists, and loops. Also, like encoding lists and dictionaries will be released next Tuesday. So just make sure you're keeping up with the checkpoints. Also, we will be talking about the final project on Thursday, and we will start to be talking about like mentors on Thursday. So just so everyone's prepared, and there will be a final project proposal, but more details to come next week.
Aha, okay. Announcements. First announcement that checkpoints and also final project stuff is coming up. Don't worry about it too much, but don't forget about it. Also, homework 4 is released. It's due Tuesday, February 25th. I checked. Also, please come to office hours. We get lonely. And it makes life easier for you and more fun for us. So the reason for your Post-it note is we're going to do a review on paper. Please close your laptops, or at least like half-mast it. So what you're going to do is you're going to write what you can remember of loop syntax, either a for loop or a while loop. I don't care which. And it's just going to be a loop that iterates through the numbers 0 through 10. Not expecting this to be perfect. I'm not even going to grade you. I just want you to be thinking about this syntax, and I will set a timer for 2 minutes. If you are watching online, please feel free to stop the video and do this with us. Thank you. You are welcome to talk to each other as well. Recording. Great job. Anyone have a hankering to share what they wrote down with actual pen and paper? Go ahead.
I equals 0 while I is less than 10, print I, and then I plus equals 1.
Perfect. There's some white space that generally you need to specify. And I have no way of specifying or like seeing what you did. But that sounds great. Any other people, anyone who wrote with a for loop? Yeah.
For I in range 1 to 11, or you could do 0 to 10. Something like colon print I.
Lovely. Does that track with everyone? Everyone kind of remember what loops are doing? Lovely. Let's get started. We've got a lot to cover. So, intro to lists and dictionaries. Lists and dictionaries are really wonderful objects in Python that have a lot of built-in uses because we are scientists and a lot of scientists use Python, and scientists are lazy by nature. And so they code up things that you can do without having to do the work that they did. So turn to a friend and talk about what you remember about lists. We've talked about it briefly in the data types section of this class, and please be ready to share. I don't need elaborate answers. I just need like a few words. And you'll get like 30 seconds.
So
30 seconds is up. I like all of the conversation. Does anyone want to share what they remember about what a list is?
Tuple that can be edited.
Yeah, that's a good analogy. It works as a tuple that can be well, tuples can be indexed. They just can't be changed. Yeah, they work like that. Lovely thing about lists. Lists in Python are analogous, pretty one-to-one with lists in Python. They are a set of things separated by a comma. Just like you need some syntax around it to see a list, you either need to see commas, maybe a bullet list, maybe the dash things, or just like a list of things going down the page. Your computer also needs these indicators. For lists, this is in general for Python, computers need specific indicators to know what they're looking at. And this is a theme that will be reiterated through the class. So for a list, you need these square brackets around your list of things. So lists are ordered and mutable. So that's some fancy vocabulary. Ordered just means they have a specific order to them. There might be a deeper CS answer to that. I don't know it. I don't care about it, to be honest. But you can go through them in order. And maybe you can start to think about a connection between lists and for loops. Mutable means they can be changed. So like what you were saying, tuples are immutable. They cannot be changed. Lists also allow duplicate values. That specification is important because of a something to do with dictionaries later on. You'll find out. Maybe I'll find out later too. So let's go to, I'm going to, just fair warning, I'm going to be coding in my terminal because I am deeply uncomfortable in VS Code. If you just open up a VS Code just like you normally have throughout the rest of, or throughout what we've done so far, you will be able to follow along. I'm just going to open up this thing called IPython. It's interactive terminal coding. Very useful. You can try and get it open, but don't try too hard for too long. So let's write a list. I am going to say, I'm going to call it new, oh Lord, sorry, new list. Great thing about IPython is it remembers some of the things that you have written in it before, but it also means that you guys get to see the crazy stuff that I type into my terminal on the day-to-day basis, and I'm sorry about that. What do we want a list of? Food, absolutely. How do we open this list? What's the syntax indicator? Yeah, I see drawings, brackets. So open brackets. I'm going to do a string. So this is going to be a list of strings. A list does not need to contain all one data type, but because we're talking about food, I'm going to do breakfast food specifically. So let's actually call this breakfast. I love breakfast. We're going to call it French toast and eggs, and feel free to call out your favorite breakfast foods. Pancakes, thank you. Anyone else? Bacon. Got some meat eaters in the house. Lovely. I'm partial to sausage. Any sort of pork in my breakfast is very welcome. Hey, cool. So now we've got a breakfast. Let's print breakfast. That's a list. That's a really fun list. I like breakfast. Feel free to play around with that a little bit more. I'm coming back to here. We're going to be a little bit back and forth between code and slides. Let me know if you need me to slow down or go back to something. Yeah, so as I mentioned, this is generic how to make a list. You've got a list of value 1, value 2, value 3, etc. unto infinity if you would like an infinite length list, which I don't. That sucks. Mixed data types are allowed. You can have ints, floats, strings, booleans. You can also make an empty list. I don't know why that would be useful, but it is. Sorry, I do know why that's useful. Let's continue. So, okay. This is your syntax for accessing a list. By accessing, we mean getting elements out of that list. So unfortunately, actually fortunately, but kind of unfortunately, lists are this thing called zero indexed, which means that the first index is 0. So the thing that we as humans call first, computers call zeroth. It has its uses. And so if we have this list here, what do you think would happen if we said print fruits of 1? Yeah.
The print apple.
Would it print apple? To print apple, you would need to say print fruits of 0, because this is the zeroth index. This is the first index. We are calling fruits of 1, which is the first index, which would be, everyone together now?
Banana.
Thank you. Yes, you are welcome to shout out in this class. What would fruits of 3 give you? Great. Love it. Wonderful. Thank you. Yeah, so I just want to draw your attention to something interesting. What is the length of this list? So there's a difference between the indexes and the length. Yeah. 4? Yes, there are 4 things in there. Length of the list is 4. That's really useful for some very interesting reasons. When I call range, I'm gonna kind of jump to something slightly tangential. When I say for I in range, so that range function, if I say range of 10, what is the last number in that list that I've created? Is it 9 or 10? 9, I'm hearing 9s. Thumbs up, middle down. Do we agree with 9? Lovely. Yes. So if I said for I in range length of fruits, so if I called len on fruits, I would get 4, right? We've agreed on that. So if I say for I in range length of fruits, and I said print I, what is the last number that would print out?
3.
3? Thumbs up, middle down, 3. I like it. Let me show that. So right now we have our breakfast list. It has 1, 2, 3, 4, 5 objects. We can confirm that by saying the length of breakfast. 5, great, 5 objects. For I in length of breakfast. If I print I, oh, shit. Length, range breakfast, my bad. Sorry, range length. Range of length of breakfast. 0, 1, 2, 3, 4. These numbers are the indices of each of the elements in this list. So remember how we index things. So if I wanted to iterate through and print out every element in this list, how could I go about that with the things that we've learned? I'm not going to force you guys to answer this, but I will give you a second to cogitate. I'm going to say for I in range length of breakfast, if I say print breakfast square brackets I, so I'm indexing I get printed out French toast, eggs, pancakes, bacon, and sausage. So this is where we start to see that loops and lists are useful together. Range itself, if you call list on it, it will give you a list. It is a list object. that you can iterate through. And we'll see that a little bit more later as well. Ooh, that's spicy. You don't want to see that. Okay. So let's talk a little bit more about some cool stuff you can do. Negative indexing accesses the last element of the list. So fruits of -1 will give us. Great, yes. Yeah, but okay, why do we need -1? I know that it looks like there are 4 elements in this list. Why would I need -1? It's useless. Like there's no reason, like it's degenerate. Like there's no reason for us to have 2 ways to access great. Besides who, yeah.
This is like really long, and you don't want to recount, you can just, and you want to access the last one.
I really like that answer because I am lazy and I don't like counting. Yeah, sometimes you don't know the length of your list. Sometimes it's just easier to go from the back. Similarly, fruits of -2 will give us orange. Irritatingly, our negative indexing is not 0 indexed. So the last element is not -0 for kind of a good reason. But it does mean you have to remember that the last index is -1 where the first index is 0. That's a memorization thing. I asked you that. You can also modify a list. Like we mentioned, lists are mutable. You can update and change them. So if I say fruits, where will I see cherry now? So if this list is apple, banana, orange, and grape, if I say fruits 1 equals cherry, am I going to end up with a list of 5? Or am I going to end up with a list of 4 where index 1 is replaced by cherry? Still a list of 4, yes. Thumbs up, middle down, agree or disagree with we're going to keep a list of 4. Yeah, let's see it. Let's see what's going on there. Okay, what am I replacing? Okay, eggs are $10 a carton now, so we're gonna get rid of eggs. So we're gonna say breakfast eggs is index 1. Breakfast 1 is equal to quiche is eggs too. Cereal? Cereal's good. And now if I say breakfast, haha, cereal. And the length of breakfast is still 5. Great job, guys. Let's keep going. There's a lot of things you can do with lists. Like I said, Python has a lot of things for people who are very lazy. I am very lazy. Please don't just look at this list and be like, I have to memorize this. You won't be able to. I don't know all the lists. Like, I didn't know that dot clear was a thing. I had no idea. I kind of don't know what it would be used for, but I'm sure I'd find something. Go to documentation or type up how to clear all elements from a list. And it'll come up with dot clear. Or it'll say reinitialize an empty list, which is what I would go for. Let's look at some of the implementations of these. Appending means to add an item to the end of the list. Nums.append 6. Will this list, so this list has a length of 5. If I append something to the end of it, what's the length now?
6.
6, great. So if we print out nums, instead it will be a list 1, 2, 3, 4, 5, 6, which is very nice, very lovely. Dot insert. So we saw in the last example of changing something that it doesn't alter the length of a thing, or it doesn't alter the length of a list. But if you do dot insert at index 1, it will add something else at that index, shifting everything else up by one index. Let me show how this works. So if I do breakfast dot insert, I don't know. I'm gonna do it at index 1 because I'm not original.
Leftovers.
Leftovers, yes. Leftovers are some of the best breakfasts, especially if you had breakfast for dinner. Breakfast. If I do breakfast now. Leftovers. I forgot the S, but that's okay. Lovely. You can remove elements with dot pop or dot remove. I don't know the difference between them, but there is a difference. I think one of them creates a new copy of your list and one of them doesn't. The way lists are done in the back, on the back end, and by back end I mean how they're how we work with them on the low level. So like assembly language, maybe C, how computer scientists work. I have no clue. There are a few things I understand better than others. This is not one of the things I really understand. But these are both things you can do to remove the third index. Now we're going to move on to dictionaries. Please be ready to share. What do you remember about dictionaries? Like before, 30 seconds. Okay, I'm gonna stop the timer. Stop that. Okay. Any ideas? What's a dictionary? And shout out. I don't care. You're so rude if you talk out of turn. I have to call. I have to call on you. This is high school. No, ideas, please. I can kind of see where you're going with that. I heard another voice. Great job. You're on the right path. Okay, if not, yeah.
Is it like a list, but each group of things has some class?
Class is a specific word in coding, but I get your general drift. You're also on the right track. They're a little more confusing. Dictionary is it's a set of things, which is so useful of me to say, I know. Unfortunately, dictionaries in English are not as one-to-one as lists in English to lists in coding, but they kind of work the same way, right? You have a word that means a definition. If I say the word definition in your brains, what appears is, or what you understand is the meaning of a word. That's what a definition is. The definition of definition is the meaning of the word. So you can kind of think of these key value pairs. You can think of the word you're defining as the key, although the key does not have to be a word. It can be any data type you would like. And it means something. That's the value part of the key value pair. Dictionaries are not ordered, so they do not have indices. You cannot index into them. And they are mutable, so you can change them similarly to lists. These do not allow duplicate keys. Remember how I was talking about how lists allow duplicate values? This is why it matters. Sorry. I get a little dramatic. Cool. So this is how we would create a dictionary. Dictionaries are created using curly brackets. You can also initialize them with the keyword dict, D-I-C-T, and then parentheses afterwards, but this is the easiest way to initialize a dictionary. There's a few key syntactical things going on here. One, note the curly brackets. Please, if you try to do this with square brackets, it's gonna yell at you. It will not know what you're talking about. The value or the string in this case on your left is the key. The colon says define as this, and then the value on your right is the value. So in the computer's head, the word name is defined as Charlie. In the computer's brain, this key is a proxy for the value that it is defined as in this dictionary. Just like a word is a proxy for a meaning, or or a number is a proxy for a quantity. You know that if I say I have one mug, this is what I'm talking about. Similarly, you have to be very specific when you're talking to computers. So let's make, yeah.
How does this like?
Question.
So can you have, the same value for two?
Yes, absolutely you can.
How does this differ from saying like name equals Charlie or age equals 22?
If I say, so like instead of defining my dict and then name colon Charlie, I just have a variable called name and define it as Charlie. Is that what you're saying? Yeah, that is a good question. It kind of depends what you're trying to do. A variable is a very specific thing in Python. It is quite literally a wrapper for a value. So if I say something like name equals Charlie, and I call name means Charlie in the computer's memory. But then if I want to define another name equals Brianna, name, where did Charlie go? I'm standing right here, guys. So basically, it depends what you want to do. The difference, though, is that a variable in your Python kernel is something different than a key. And it can be replaced. You can replace within a dictionary the key value or the value for a key. But you can define a new dictionary to mean Brianna. So you can have two dictionaries. And they can contain the same information about two different people. So it's kind of it really does depend what you want to do. And often people kind of, well, I know when I learned about dictionaries, I was like, why the hell do I need to use these? They're very useful in data. So let's define a dictionary. We're going to call it Charlie. Because I am vain. We're going to say my name is Charlie. Charlie. My age, I am 22. I'm getting old. And I say my favorite color is orange. I'm gonna end that. I'm gonna say Charlie. Wow, that is a dictionary. It's not really useful though if I can't get at the stuff in there. So let's look at how to do that. Accessing elements. You access values in a dictionary with their keys. So this is the same dictionary that I just coded into my Python kernel. If I call the top one my dict of name, what am I gonna get? I'm hearing Charlie. I like the sound of my name. Thumbs up, middle down on we're gonna get Charlie. Yeah, I would agree. Charlie of name. Yeah, Charlie. I love seeing my name so many times. As we've noted before, the double and single quotation marks do not matter. So you can kind of do it however you want. And then similarly, my dict of age will be 22 because I am 22. You can also access elements in another way. That's a little bit more general. You can loop through keys. As we know, our keys are name, age, and favorite color. If you called my dict dot keys is a built-in function that works with dictionaries. They are iterable, which means you can say for an element in this thing, print it out. So you can iterate through this object, but you cannot index it. So let's try to do that. We're gonna call it Charlie Keys is equal to Charlie.keys. And if I print out, don't do that. If I print out Charlie Keys, this object, the dict keys object, if I say for I in Charlie Keys, print I, what am I gonna get? Cogitate. Shout out if you have an answer. Yeah.
Name, age, favorite color.
Yeehaw. Let's make this slightly more interesting. What happens if I say Charlie of I? What am I gonna get? I'll scroll back up because I know you guys haven't memorized all of the fun facts about me. If I say for I in Charlie Keys, print Charlie of I, what do I get? Another way you can use loops to access things in a collection. And then there's another way, which is with the items built-in function. So Charlie items is equal to Charlie.items. This one's interesting. If I say for I, comma, D in Charlie items, print I, comma, D, name Charlie, age 22, fave color, orange. Pretty cool. Very useful. It doesn't seem like it right now, probably, unless you are you have more foresight than I do, or than I did when I was 20 years old. 19? Whatever. And then, yeah, okay, I'm gonna keep going. You can also modify a dictionary in the same way that you can modify a list. Remember, we said list 1 equals cherry. The list changed. So if I say my dict of fave colors is equal to gray blue, I decided to change it around a little bit. What's gonna change in my dict? My favorite color. And what part of that key value pair is going to change? Is it the key or the value? Do we agree, thumbs up, middle down, that the value is going to be the thing that changes? Yay, I like that. Okay, let's do it. Let's say Charlie of fave color is equal to gray, blue. A, not E, because we live in America. And if I say Charlie, my favorite color is now gray blue. That's crazy. So what do you think would happen if I use the syntax, but the key that I am trying to change doesn't exist in my dictionary? Will I get an error or will it work? Fingers up for 1 error, 2, it'll work. Seeing a lot of ones, but I'm tricky. Sorry. So let's try this. What am I going to tell you guys about myself? I'm going to tell you my hometown. Hometown is equal to Winters. Reason I'm telling you this is because I don't think any of you know where that is. Whoa. That did not throw an error. That's very interesting. You can add a new key value pair in the same way that you change a key value pair, just by saying Charlie new key is equal to new value. Questions? What questions do we have? Okay. Can also remove things. Oh, I didn't change this one. That's okay. Brianna, we're using you now. Are you still 20? Okay, that's fine. So, well, that's good. The example here is if you take out the age and replace it with favorite number. Yeah, I remember that. I went through and changed all the slides. I guess I just missed this one. 42 is definitely the best number. If you don't know what that means, you can ask me or you can ask the internet. It's a very good it's a very good number. It's the answer to life, the universe, and everything. Yes. Yeah, so you can delete things. That's helpful. And then that's about all I'm going to cover specifically about dictionaries. So now we can talk a little bit about how they're different from each other. Lists, you have something ordered. You can even have a list as a value for a dictionary, which is really nice because sometimes you want to store sets of data with an identifying key. And there's good reasons for that. It makes data storage and conversion to file types or to files a lot easier. And we'll talk about that more when we get to data. And then when you only need to reference something by a position, you can loop through lists. Lists are everywhere in Python. Dictionaries, not quite as ubiquitous, but when you need to store values as a key value pair, like I wanted to store the position of Mars over the course of a 24-hour period. So I might say Mars position is my dictionary. I set it equal to a dictionary and I say position is, or like right ascension is something, declination, something else. And then I can convert that into position around the sun. Coordinates are not my forte, but basically, that's basically it. And then when you need each item to have a unique identifier, it's very useful, wonderful. Now we can talk a little bit more about how things combine and work together. We've been talking a little bit about for loops and iterating through things, but we can talk a little bit more about stuff. Slicing and striding. That sounds weird. Slicing lists. It's kind of exactly what it sounds like. You're chopping things off of it. It doesn't change the actual list that you are slicing. It just gives you a new subset of that list. And you do it with indices. So if I say nums is equal to 1, 2, 3, 4, 5, and then I set sub nums, as in subset of nums, equal to nums from 1 to 4, what am I going to get? What's the list? So I'm going from index 1 to index 4, where index 4 is not inclusive. So it's not going to give me back whatever's at index 4.
2, 3, 4.
2, 3, 4. Do I have thumbs up vote for 2, 3, 4? I also agree with that. Sorry. New list is equal to 1, 2, 3, 4, 5. Nums is equal to new list of 1 through 4 and nums 2, 3, 4. Wunderbar. Striding is kind of a more general version of slicing. If I had a big long list and I only wanted like every other item from index to index, then striding can be very useful. But yeah, it's basically a broader version of slicing. You can see the pattern is slightly different. That's because with this syntax, the default is that step is equal to 1. So for example, here, I said from 1 to 4, in the computer's brain, I say brain, computers are dumb. In the computer's brain, there's a third number there, and it's the step. So if I say nums 1 is equal to new list of 1 for 1, and I call nums 1, still gonna get 2, 3, 4. You get some weirdnesses, which you can explore as you go. If I print new list with no start and no stop and a step of 1, what am I going to get? Am I going to get nothing because there's no start and stop? I hear a no. I see a hand.
It'll be from the back front.
Back to front?
Well, it'll just be like start to.
Yeah. It's just going to be, if I can spell, it will. Yes. Yeah, still 1, 2, 3, 4, 5. Interestingly, you can go back to front. If I add a negative sign. 5, 4, 3, 2, 1. That reverses it. So that's a backwards step. And you can combine that with your negative indexing as well. So that's that. You can loop through elements as well as indices, which we've hinted at when we talked about range, because range is an iterable object, like a list. So I said before, for I in range length of list, print list I. But if I say instead for I in a new list, print I, just gonna get 1, 2, 3, 4, 5. Because you're iterating through elements. There's works for any list, or for food in breakfast, print I. Why did it print out 5s instead of a food stuff? What happened? What's going on there?
We're printing I instead of food, but I still don't know why it's 5 specifically.
It's 5 because the last I that we access in this for loop was 5. So the last number that I was defined as, it's still going to be defined as. So let's print food instead. That. There it is. And if I print food now, sausage. So food is defined outside of the end of the for loop. Unlike in functions, where if you define a variable within a function and you don't return it, then it is not defined outside of the function. All variables in a for loop, I think with exceptions, all variables in a for loop are global, which means they're accessible. There's a few other things we can do, like concatenate. If you just add the two lists, these lists will be back to back. Dot append will append the list as a value to nums1, which is interesting and can be very useful. And it is 4:30 now, so go home or go to my office hours. I like having people in my office hours. Thank you for coming to lecture, and feel free to come up and ask us questions.